let's take a look at two basic examples of being able to decompose fractions. All right, so we have this 3x plus 2 over x squared plus 4x plus 3. All right, so first thing we need to do is we need to try to determine what types of factors we have in the denominator. And so what we should do is we should always start by factoring the denominator. Okay, so this is going to become 3x plus 2 divided by, and we know that this is going to factor into x plus 1, x plus 3, since 3 plus 1 gives us 4. Notice what we have is we have two distinct linear factors. Okay, so if we, in our previous video, we defined what we meant by distinct and linear. Okay, so this is going to be equal to a over x plus 1 plus b over x plus 3, okay, since we have distinct linear factors. All right, now our goal is to solve for a and b. All right, so here's how we're going to do that. We are going to multiply everything by this common denominator of x plus 1, x plus 3. All right, so I'm going to multiply this by x plus 1, x plus 3 on the left-hand side. I'm going to multiply this by x plus 1, x plus 3. And then I'm going to multiply this by x plus 1, x plus 3. All right, now you think that this might be a mess, but in fact, it cleans it up nicely. So these cancel out, and the x plus 3's cancel out. And so now we're left with something that's not all that bad. Okay, so the resulting equation is going to be 3x plus 2 on the left-hand side, a times x plus 3, and then b times x plus 1. Okay, so again, these cancel out, x plus 3's cancel out, and everything cancel out. Now, what I'm also going to do is I'm going to distribute the a and the b to both of those terms. Okay, so we get ax plus 3a plus bx plus b. All right, now what I want you to notice is that the left-hand side has to equal the right-hand side. So I'm going to redraw these. All right, so give me a second. And I'm going to redraw anything with an X in it in red. Okay, so just so you can see what's going on here. Right? So remember, we had 3x, we had ax, and we had bx. Now, I want you to know that these terms have to be equal for this equation to be true. So what I could do is I could set up an equation, and we could say, and we're only going to do this once, we're not going to do it again. We could say that 3x plus is equal to 3ax, or I'm sorry, is equal to ax plus bx. But we really don't care about x. All we care about is solving for a and b. And so this means that 3 equals a plus b. All right, so basically anything that has an x, what you're going to do is you're just going to take the coefficients and make an equation out of that. Now, also, I want you to notice that we have that 2 is equal to 3a plus b. Those are constants. They don't contain any powers of x. So another equation that we get out of this would be 2 equals 3a plus b. And folks, what we have is we have a system of equations. Okay, so what you're doing is you're matching up the powers of x as to the left-hand side and right-hand side, and then you're matching up the constants. To solve this equation, or this system, what I could do is I could multiply the first equation by -1. And that's just because I noticed that the b's are close to one another. And so this would give me that -3 is equal to -a minus b for the first equation. 2 equals 3a plus b. Those would cancel out. -3 and 2 is -1. -a and 3. A is 2a. So -1/2 is equal to a. Now we also know that a plus b has to be equal to 3. So 3 equals -1/2 plus b. If we add a half to both sides, 7/2 equals b. And so what I'm going to do is I'm going to put these back into the original decomposition. Okay, so now I'm going to plug them back in for A and B. Remember we said that A was negative 1/2 over x plus 3, or x plus 1, excuse me. So we're just plugging back in here. So that's negative 1/2 over x plus 1 plus 7/2 over x plus 3. Another way to write this, and this is probably the cleanest way to write this, I'm going to take the negative out front, and then I'm going to move the 2 to the denominator. Okay, so I'm going to write that as negative 1 over 2x plus 1. Over here, I'm going to keep the 7 in the numerator, take the 2 to the bottom, and get x plus 3. Okay, that would be our partial fraction decomposition. Now, of course, if you don't trust it, what you can always do is just add these back together. Okay, and you should end up with this expression. Okay, I'm not going to do that just because we already know how to add fractions, and we certainly think that this is going to be correct. A second example of distinct linear factors. So we have 2x squared minus 3x plus 4, x cubed minus 7x squared plus 10x. All right, so let's start by factoring the denominator. Okay, so 2x squared minus 3x plus 4. We don't want to worry about that. I'm going to factor in x out of the denominator to start. So that leaves me with x squared minus 7x plus 10. And then I'm going to factor this trinomial. Okay, so I get 2x squared minus 3x plus 4 divided by x. This is going to factor into x minus 2, x minus 5. And so what we have is we have, again, distinct linear factors. So this is linear, this is linear, this is linear, okay, for our three factors. So what we can do now is we can rewrite this as 2x squared minus 3x plus 4 divided by x, x minus 2, x minus 5. Since they're distinct linear factors, a over x, b over x minus 2, c over x minus 5. Okay, so every linear factor gets its own undetermined coefficient. All right, now here's the tricky part. This is the algebra intensive part. We are going to multiply everything by the least common denominator. Okay, so I'm going to multiply this fraction by x, x minus 2, x minus 5. I'm going to multiply this fraction by x, x minus 2, x minus 5, x, x minus 2, x minus 5, and then x, x minus 2, x minus 5, right? We're going to simplify, all right? So everything cancels on the left-hand side from the numerator denominator from multiplying, and we're just left with the original numerator. Over here, the x's cancel out, the x minus 2's cancel, and then the x minus 5's cancel. Okay, so here's going to be the resulting equation. So again, we have 2x squared minus 3x minus 4. We have a, x minus 2, x minus 5. Okay, so what I did was I just canceled out these x's right here, right? And I was just left with this. X minus 2's cancel, so now we have bx, x minus 5, cx, x minus 2. All right. Now, unfortunately, I know it's ugly, but we are going to FOIL out the right-hand side, okay? And then we're going to try to match up powers, okay? So we get 2x squared minus 3x minus 4 is going to be equal to, now if I FOIL this out, don't we already know that this x minus 2, x minus 5, wasn't that x squared minus 7x plus 10? Because we factored it right here. So it should be the same thing, okay? So when we distribute the a to these three terms, ax squared minus 7ax plus 10a. Now we distribute b, so we get bx squared minus 5bx, and then cx squared minus 2cx. All right. Now, remember, all the powers of x have to be the same. All right. So if I look at all the x squareds, I have 2x squared on the left-hand side. I have ax squared, bx squared, cx squared. Okay. So one equation that we can generate from this is going to be that a B, and C. So A plus B plus C has to be equal to 2, okay? Because all the coefficients on the left-hand side of x squared have to be equal to the coefficients on the right-hand side. So what I always do is I always just circle the coefficients, and I just basically ignore the x squareds, okay? Because we don't care about x as long as the powers match, okay? Now, another equation is going to be when we look at the x's, okay? So we have a -3, we have -7ax, we have -5bx, and we have -2cx, okay? So the equation that's going to be generated from that is going to be a plus, or I'm sorry, -7a, excuse me. So -7a, and then -5b, and then -2c is equal to -3, okay? Now, finally, the only thing that's left is this animal right here, A. And that's good because we get that 10A is going to be equal to -4. All right. That's going to help us a lot because that's going to help us to solve this system rather easily. Okay. So if 10A is equal to -4, we can divide both sides by 10, and that gives us that A is -2/5 right away. And what we could do is we could substitute back in to the other equations, and that way we could just get a nice equation in 2 variables. Okay, so looking at equations 1 and 2, we get -2/5 plus b plus c equals 2. -7 times -2/5 minus 5b minus 2c equals -3. All right. Now, we're just going to add 2/5 and then subtract 14/5. Okay, so we're going to get a new system out of this just by moving everything to the right-hand side. So we get b plus c. If I add 2 to 2/5, that should wind up being 12/5. But of course, if we don't trust that, we can just use our calculator and we can just do 2 plus 2/5 and then put that in the fraction form, and we're going to get 12/5 out of that. Over here, we know that's -7 times -2 is 14/5, and we can take -3 minus 14/5 since we're subtracting it from both sides. Okay, so we get -5b minus 2c, and that's going to be equal to, that should be -29/5, but again, we'll just use our calculator. So we get -3 minus 14/5, and that's going to be -29/5. I'm going to multiply the first equation by 2. All right, and the reason I do that is just because that's going to give us a positive and a -2c. Okay, so we're almost done with this. We're getting close. So our new system is going to become 2b plus 2c. 2 times 12 is 24/5. We still have -5b minus 2c equals -29/5. And this is going to work out really nicely. Okay, so the 2c's cancel out. We get -3b. 24 minus 29 is a -5/5 or a -1. And so that means that b is going to be a positive 1/3. Finally, we know that b plus c is 12/5. So we can just back substitute. So we have 1/3 plus c is 12/5. And then we can just go in our calculator, subtract 1/3 from both sides, right? And 12/5 minus 1/3. And that's going to give us 31/15. Okay, so that's 31/15. All right. So last thing we need to do is we need to go all the way back to the beginning where we had these partial fractions and fill in for A, B, and C. Okay. So remember that A, we said, was -2/5. So we have -2/5 over x. We had B was 1/3. And remember, the denominator for b was x minus 2. And then finally, we had 31/15 x minus 5, right? Another way to write this, we pull the negative out front. So we have negative 2 over 5x. We put the 3 in the denominator here. So we have 1 over 3 quantity x minus 2. And then finally, 31 over 15 x minus 5. Okay, and this is going to be our answer. Okay, let me erase that since the negative should be included in the box. All right. Again, if you don't trust the answer, what you should do is just add these fractions together. All right, but that might be more painful than it's worth. Okay, so those are two examples of distinct linear factors. In the next video, we're going to take a look at repeated linear factors and see how we handle those.